Okay, so today we're going to be talking about slope-intercept form and the key attributes of a linear function. You may have seen this before, y equals mx plus b. That is going to be our equation for a linear function in slope-intercept form, and we'll go over that here in a minute. So our goals for today, our lesson objective, we will be able to identify key attributes of linear equations and write the equation in slope-intercept form. Our language objective. We will collaborate with our peers on identifying the slope and y-intercept of linear equations. We will also be able to write linear equations in slope-intercept form. Our essential question, how can key attributes be used to describe the behavior of linear functions? So slope-intercept form. So it says Liam had $10 in his savings account. He plans to deposit an additional $5 each week. Liam wrote an equation and created a graph to show the relationship between X, the number of weeks, and Y, the balance in his savings account. So just by reading the equation, I already found some key stuff that I've underlined. I know that $10 is the starting amount that Liam has in his bank account. I know the word deposit means adding, because we're adding into the amount that he already has. And I know that the word each means to multiply. We're multiplying $5 each week. Okay, so now we're going to go ahead and read through these questions. It says find the slope of the graph. And then it says, where do you see the graph in Liam's equation? So the first thing we have to do is we have to find two pretty points. Pretty points are the ones that will go either between two lines if it's on an edge or between four lines. So we're going to find two pretty points and it doesn't matter which ones. So I found a point here and I found a point here. They both look pretty. It looks like almost any single line on here would be pretty, but you can pick any two lines to go ahead and find it. So now we're going to use rise over run to go ahead and find our slope. So from the 2 points that I picked, I'm going to figure out how much it rises. And that should have went first. So I found out that it rises this much and it goes from 20 to 30. So it goes up 10. So my rise is 10. Then I want to find my run, and it's going over 1, 2, so over 2. And I could simplify that more because I know 2 can go into 10, and I'm going to get 5. Now the second part says, where do you see the slope in Liam's equation? So my slope is 5, and I see 5 right next to x, which makes sense because I said I'm multiplying 5 by the week, and x is the number of weeks. Then it says, where does the graph intersect the y-axis? Well, the y-axis is going to be our vertical axis. And so we're looking for where this graph intersects it, which is going to be, an intersect is where it touches our crosses. And we're looking for the y-axis. So we're looking for this point right here. And this point says 10. And where do I see 10 in Liam's equation? Well, I see 10 right here. It's the amount that we're adding, which is the word deposit, to our initial value, which is the 10. So we add our initial amount, which is 10, to the $5 each week that we save. So I found the key parts to this also by reading the equation. So slope-intercept form. Slope-intercept form, or y equals mx plus b, is one way to write an equation of a linear relationship, where m is our slope and b is our y-intercept. Use the definition of slope and the intercept to answer the following questions. And I will fix this when we do this in class. That's a little mistake that happened. I forgot to put the action on that. So we know our slope-intercept form is y equals mx plus b. We know our slope is m. And so in the same position that m is right next to x, they're always going to be touching. They're right next to each other because they multiply is going to be 2.5. And the thing that we're adding, our initial value, is going to be b, which is 4. Not too bad. You're just looking for placement. Anything directly touching, multiplying by x is going to be our slope because our rate of change is directly connected to our x, our independent variable. It's the amount that we're changing each time x increases. And then this is going to be our intercept, our starting value. So now we have another equation. So we're going to go ahead and look at y equals mx plus b. So our slope is whatever is touching x. It's being multiplied by x. So our slope for this one is -1/7. And then I don't see any number that we're adding or subtracting. So if we don't see anything, it's the same thing as adding 0. So if we look at that now, our b is going to be 0. That's another way of saying that it's going to start at the origin. Okay, so we have another one, y equals mx plus b. We're going to identify what's next to x, and it's just a negative. So if it's a negative, that means it's going to be -1. And this time we're not adding, we're subtracting. So no, we're going to negate it to make sure that we can do subtraction. And so we're going to have a -8. So it's going to start on a -8, so under the x-axis. So we have y equals mx plus b, but what I notice here is that it's not in the same format that we've been using. So you got to pay attention. They do try to trick you sometimes like this. You have to pay attention to your x. Your x is next to slope, while when you have a constant, your constant is going to be your intercept. So x is next to your slope is next to your variable, it's next to x, where your constant is the b. So that means my slope is going to be 3/2. And my constant for my slope intercept is going to be 15. So now we're going to write the equation in slope intercept form for each graph. So we have to find the slope, we have to find our intercept, and we have to write the equation. So of course, to find slope, we need 2 pretty points. So we're going to look for 2 pretty points. I like this one, and I like this one. And they could be any 2. I could have found one right here, and I could have found one right here. It doesn't matter which 2 points you pick, because once you simplify, you're going to get the exact same slope, because a linear function has a consistent rate of change. So the rate of change between any points will be the same. So we're going to go ahead and we're going to find our rise, which is actually going down. So it goes down 2, 4, 6, 8, so -8. And it goes over 1, 2. So we're going to have -8 over 2, which I can simplify into -4. So my slope is going to be -4. Now for my intercept, I have b. So I'm looking for it crosses the y-axis, which is going to be right here. And that number is going to be 18. So now when I write my equation, I'm going to write it in slope intercept form. So it's y equals our slope, which is -4x plus our b, which is 18. So y equals -4x plus 18. Now we're going to do the same thing here. We're going to go ahead and we're going to find our slope with any 2 points that we want to use. So I'm going to use this point, and I want to use this point. There's a lot of other pretty points. That one's not pretty. That one's not pretty. But there's several other pretty points in here, but I chose those. So we're going to find our rise. So we go up 1, 2, 3, 4, 5, 6. And we go over 1, 2, 3, 4. And so our slope is going to be 6/4, which we could also simplify. And we're going to get 3/2. So my slope is going to be 3/2. Now I need to find my y-intercept where it crosses the y-axis, which is right here at 3. Which I could have used that point when I was finding my slope as well. But it's going to be at 3, so my y-intercept is 3. So when I write my equation, I have y equals 3/2, so 3/2 x plus 3. So all we're doing is we're finding our slope, which we've already learned. We've done 2 days on slope. We're finding our intercept, just the place where it touches and crosses the y-axis, and we're writing it in slope-intercept form. Let's do another one. We're going to find our 2 pretty points. I like this point, and I like this point, and I like this point. So I'm going to use these 2 points here. I'm going to find my rise, which is going down 1, 2, so -2. And my run, which is 1, 2, 3, 4, 5, 6. So my slope is going to be -2/6. I can simplify that, and I get -1/3. I need to find my intercept. My intercept is right here. I'm sorry, I put the -1/3 there. My intercept is right here, and that value is -2 because it's below the x-axis. So -2. And when I go ahead and I write I put the wrong equation in here. This should say -2, so I'll fix that. So this is y equals -1/3 x minus 2. And I'll fix that when I redo this. And 8 minus 10, plot your y-intercept, then use the slope, rise over run, to plot a second point on the graph, and then draw a line connecting the 2 points. So we're going to plot our y-intercept. My y-intercept is -4. So I'm going to put a point at -4. This is I'm going to go up 2, 1, 2. I'm going to go over 3, 1, 2, 3. I'm going to plot my point. I'm going to connect my line. So not too difficult. I only needed 2 points. Sometimes when you're doing it by hand and you don't have a tool that's going to create the line for you, it's a little bit easier to write more than 1 point. So you can try to get it perfect. So we're going to do the next one. We're going to plot our intercept. 45, 45. This -5 means it's going to go down 5. So we're going to go down 5. See, this is 45 to 40, so it went down 5. And if there's no denominator, it means 1. No denominator means 1, so it's going to go over 1. Then I plot my point, and I connect my line. Now this is where it started, and it's going all the way down. My next one, I have -1/2 x. So no b means it starts at the origin, so it's going to start here. And it goes down 1. But because we're going by 2s, -2, -4, -6, -8, I'm just going to double the slope to make it easier to graph. So it says down 1, I'm going to go down 2. So I'm going to go here. Then I'm going to go over 2. So because I'm doubling, I'm going to go over 4. I'm going to plot right here, and I'm going to connect my lines. So when you graph on IXL later on, you're just going to have to plot the 2 points. So find the intercept and then plot the second point. I'm going to show you all the steps if you're graphing it by hand, if you happen to do it on scratch paper. Okay, so the graph shows a linear relationship between the number of minutes Ingrid has traveled and the number of miles she is from her work. So write an equation for the graph. So of course, 2 pretty points, 1 pretty point, 2 pretty points. It makes it easy when I use the axes, because when I use the axes, I know that value, and it's going to go all the way down to 0. That value is going to go all the way over to 0. So it's easier to count. So I have 24 going down to the origin. So it's going down -24, so -24. And I'm going to go over to 18. So I'm going to go over 18. So my slope is going to be -24 over 18, which I could simplify to -4/3. Now we need to find our intercept. My intercept is right here. It crosses at 24. So my equation is y equals -4/3x plus 24. So now what is the rate of change and what does it represent? Well, my rate of change is the same thing as saying slope. They're equivalent. And I already found that my slope is -4/3. And what it's representing in this situation is as Ingrid drives, the closer she gets to work. So the longer she drives, the closer she gets to work. If she drives 0 minutes, she's 24 miles away from work. If she drives 3 minutes, she's 21 miles away from work, or just about, and a little bit off here, but if she drives 9 minutes, she's 12 miles away from work. So the longer she travels, the closer she gets to work. What is the y-intercept and what does it represent? Well, my y-intercept is 24, and that's when I haven't traveled at all. That's when my x is 0. So that's the number of miles she has to travel to get to work. She hasn't traveled at all, so she's 24 miles away from work. So when y is 0, what is the value of x, and what does that point represent? So when y is 0, we're going from the origin to our x value, and our x value is 18. And that means she's got 0 miles left to travel. So she's at work, and it took 18 minutes to get there. So 18 minutes, and this means how long it'll take Ingrid to get to work. So when you're looking at your intercepts, you have your y-intercept and you have an x-intercept. It's just taken in the context of the problem. This is when she hasn't traveled any and how many miles she has left to get to work. And this is when she's arrived, and took her 18 minutes to get there. And the next slide is going to go into that a little bit more. So we have key attributes of linear functions. We know the slope already. So the slope is the rate the linear function increases or decreases. Slope is always multiplied by x in slope-intercept form. So it's always going to be the thing next to x. And we have different ways to represent slope. Rise over run, delta y, delta x. M is our letter for slope. y2 minus y1 over x2 minus x1. And the change in y over the change in x. These are things that you've seen over the past few days, and they all represent slope. We have a y-intercept. The y-intercept is the point of the line that touches or crosses the y-axis. This is usually considered your starting or initial value, and this is the point where x equals 0. So you know it as the letter B, and if you're looking at an ordered pair, x equals 0 and y equals b. So whatever the y value is, it's going to be b. And next you have your x-intercepts or zeros. The x-intercept is the point where the line touches or crosses the x-axis. This can be thought of as the ending value in some scenarios, just like our scenario before. She had finished driving, she had 0 miles left, and she had arrived at work, and that's how long it took her. So in some situations, our ending value. And other terms, it can keep going past that, but there is going to be a number that represents it. This is also referred to as a zero. The reason it's called a zero is because if you set the expression to 0 and solve, you will get the point of the graph. So this could be thought of as 0. So if someone asks you for a 0, that means they're asking you for the x-intercept. And this is the ordered pair, the x value, comma 0. Because y equals 0. Okay, so when we're in class, we're going to go ahead and practice what we learned, and we're going to do a quizzes on the key attributes of linear functions. You're going to have to identify slope, y-intercept, and x-intercepts, either from the equation, a graph, or points. So these are different things that you're going to have to figure out and try and practice. After we've completed our quizzes, we're going to be doing IXL. So we're going to have 3 codes that we're doing, R5T, UWB, 9GW. When we do IXL, you want to make sure that you're doing at least 10 questions per practice set. Your goal is a 70 or higher. It shows how much you master it. So continue to go until you feel completely comfortable. And once you're completely comfortable and you've completed IXL, we do have a 3-question exit ticket for you to complete on Canvas. Hopefully this helps and you have a wonderful rest of your day. And if you need any help outside of class, make sure that you are using tutor.com or sending me a message. Bye.